Welcome back to the second video, team. In the last video, we ended literally talking about organizing information and then what we can do to take this information and then start calculating stuff. So you start with what you know, what you have, and you use that to help create some sort of initial probability. So we'll talk about that in just a second. What I mean by initial probability, we need something to start off with as we start asking some questions and looking at the different ways to organize our solutions. And then you take what you're interested in to help you create that probability, and you have some sort of numerator and denominator set up to create it. Now, if you have a numerator and denominator, you know that you're dealing with fractions. So take those fractions, convert them into what you know, so decimals or percentages, to help you start answering questions, and then ultimately start finding the probability of everything else in the problem that you may need. And then ultimately you can start calculating other probabilities using the rules and answering questions. So what does this look like if we have an example? Let's make up an example here. And let's just say we have 2 dice. Okay, we have two dice. And what we're trying to do is we're going to roll the 2 dice and we want to know the probability of a couple different things. On dice 1, first die, we roll, actually, let's rephrase this. What is the probability of rolling an even number and let's say we want to roll an even number and a 3. Okay, so using the 2 die, we want to roll an even number and a 3. The first thing that I want us to do is identify okay, we have 2 dice and we want one of them to be even and one of them to be a 3. Well, we need to start talking about the initial probabilities that we have. So here, what I'm going to do is I'm going to call it number 1. I'm going to say initial probabilities. Okay, what this means is we want one die, doesn't matter which one, we want one of them to be an even number and then one of them to be a 3. We don't care what order, we just want an even number and a 3. So let's look at some events. The probability of an even number. An even number in this problem is considered some sort of event. Same thing, rolling a 3 is also another event. So we want to find the probability of an even number and the probability of rolling a 3. In order to do this, we need to set up our initial probabilities using what we know about dice. So dice are those cubes with the various dots on them. Some of us know this, some of us don't. And on these dice, there are 6 sides. So when we're making an initial probability, we would like to put that, what we know, how many different number options on the bottom. Okay, so we have 6 sides in each dice. Now, it doesn't really matter which one we're talking about because they're both considered the same in this problem. There's not any fancy dice in that we're working with. And so we're going to start with out of 6. There's 6 possible number choices. Now, how many of those are actually considered an even value on the dice? Well, if the number goes 1, 2, 3, 4, 5, 6, we see that there's exactly 3 possibilities for an even number. Similarly, there's only 1 possibility for a 3. And so here we've established our initial probabilities. We've gathered what we knew. We created those initial probabilities. Now we're ready to set up the question to answer. So set up the question in notation form. And so here what we're looking at is the probability of rolling an even number and a 3. So if I go like this, probability of an even number and a 3, we can turn this into proper notation. The probability of an even, and I'm just going to keep shortening this, oops, and a 3. Now, we realize, and I'm going to go back really quick, this word and this symbol, which stands for the intersection of, both elicit a specific rule that we want to have. Because getting an even number and a 3, because we have two different dice, because we want an even number and a 3, these are independent events. I can roll an even number on one dice and a 3 on the other and have everything work out. Right? All because I roll an even number doesn't mean I can't get a 3 on the second one. Because they're independent and because it's an and, we're going to be using the product rule in order to solve for this. Which means we want to get the probability of an even number, and we're going to multiply that by the probability of getting a 3. And if I scroll down here really quick, we can see that this ends up turning into 3 over 6 multiplied with 1 over 6, and we end up with 3 over 36, or a 1 out of 12 opportunity. So we have the probability, and you can rewrite this in proper notation, the probability of rolling an even number and a 3 is 1 out of 12. So this could be your solution response. Okay. Now you would do this no matter what as we continue forward, and you can use this to help you determine the various probabilities using these values. So let's do another question, something similar. Let's keep working with dice. We have one die this time. We roll it only once. What is the probability of rolling a 2 or an odd number? Okay, so this is where it gets a little bit tricky because we can do a 2, we can roll a 2 easy, but we can't roll a 2 and get an odd number. This part gets a little bit confusing because there's two different outcomes. They can't happen at the same time, which means we're dealing with a mutually exclusive events. So these are exclusive events. Because we have one die, they both can't happen at the same time. The situation above here, rolling an even number and a 3, those are also exclusive, but since we have two dice, they become independent because they both can happen at the same time. So down here, because these are exclusive events, we got to go about this differently. So let's start again with our initial probabilities. Okay, and we find that the probability of rolling a 2 is going to be, well, there's only one 2 on the standard die. And then we go over here and we roll for an odd number, which is the opposite of the even from before, which is 3 over 6. Okay. Then using notation, we can convert this question, what is the probability that we roll a 2 or a odd number? Probability of a 2 or odd number we can use some different notation. Probability of a 2 or odd. Okay, and we set it up above in those notes. We have or the union. These help us see that we have an exclusive events, and then or equals to add. We're going to be adding the probabilities of these together. So we would continue here. We get the probability of a 2 or the probability of an odd number. So you get 1 out of 6 plus 3 out of 6, which makes me get 4 out of 6. Okay. So these are pretty, I'm going to say the word trivial examples, looking at the difference between the additive and product rule. And so we need to make sure that we keep that in mind as we move forward and kind of seeing how we can progress in answering some of these questions. So if we continue, we want to look at a couple different things, some differences. Let's say we're playing with some cards now, right? And a deck of cards has 52 cards found within it. Okay, and using these 52 playing cards, we pull we pull 2 cards. The first card is a heart. Okay. We do not put it back in. We do not replace it. Find the probability the second card is also a heart. So this is a different type of problem, and a lot of students think that this involves already doing the product rule, additive rule, stuff like that. However, think about what the problem's saying. We pull 2 cards. The first one is already a heart. Okay, so first pull is a heart. This was a 1 out of 52 chance that we pull a heart. Actually, that's a lie, I'm sorry. There are 13 hearts in the deck. So that's 13 out of 52, actually. Then the second pull, what we wanted was that the second card is also a heart. Well, seeing as though we just pulled one, there's only 12 left out of 52. Now, this problem just said find the probability the second card is also a heart. It doesn't say anything else about the first card in the question, right? So in this case, the probability that the second card is a heart would just be this. Now, you don't need to think into the problem a little bit. This question, the second pull is a heart, is easily answered just by looking at what you'd already did in the problem. And actually, I made a mistake here again too. Because we already pulled one out and we don't replace it, there's only 51 cards left. Okay. This question becomes different if I said, find the probability of, let's say, this happening, which is the first and second are both hearts. Okay, this is where the question now, you would need to take into account the first pull is a heart. You have 13 out of 52. And then the second is a heart. What is the probability of this happening? I'm not looking for the probability the second card is also a heart. The probability of this happening Because they both can happen, they're not exclusive events. These are independent events. One, yes, it kind of impacts the other, but they both can happen. I can multiply these together. So I would get 13 times 12 over 52 times 51. And then I could simplify these, and then I would get a certain solution that can help me out. So I end up with 132 in the numerator, 132 over 2,652 as my probability of this happening, pulling two different hearts. So there's different pieces of information that we can dissect from different types of problems, but ultimately they follow the same, you can say, fundamentals of reading through and looking at them. First, you start off with some sort of initial probability, and then you use notation depending on what kind of rule that they're asking. Okay. So we're going to stop here. We're going to talk more about it in class, but hopefully this helps you just a little bit take a look at what we're talking about and then how to organize your information as you continue forward. Catch you next time.